know that Fabric is a firm that has a unique model to invest in early stage startups. But we do our investments with a lot of due diligence and a lot of partnership with the entrepreneurs. Our goal is to make the entrepreneurs successful, but our track record is shown here. As you can see that over the last 4 years of our being in existence, a little over 4 years, we have funded 7 companies so far. So very selective, very narrowly focused, or very strategically focused, I would say, in the cloud infrastructure space, where we're looking for the disruptive technologies that define or drive the cloud infrastructure. So these companies are all iconic names now and growing in their various stages of growth. Some are in Series C and D funding, some are in A and B funding, and some are just getting off the ground. So, you'll get to know some of the people here. But they're all hiring, and if you have interest, please reach out to some of us, and we'll be happy to help you. Just quickly, Fabric, as I said, is a unique model, which is that we provide seed financing to the entrepreneurs and to help them get successful, but we also provide a very deep infrastructure and knowledge of the technology, so we help and work with them in de-risking their project, and the investment almost becomes incidental. First is to de-risk and validate the idea very significantly, and we do that with the help of Prabakar, who is the Chief Strategy Officer, and Rajan, who is the CEO of the company. And a very small team, but we work very closely with the entrepreneurs. And then we help them attract top-tier investment as well, working with various Series A, B investors on Sandal Road, and we've had successful models of all of those companies that have achieved that. So I should also point out, by the way, that at the bottom you see our your handle for tweeting. So if you are tweeting today, please do at the FabricNet. We would really appreciate that. And then where we really support the companies is in the product development area, refining the product idea from ideation to rapid validation with meeting with 10, 15, 20, 50 customers in the beginning. They're not even customers, they're really prospects, but we validate the idea with them for the entrepreneurs, and then help them with building the team, because a lot of these entrepreneurs often get so busy with the MVP and getting the product developed that we need to build a core team, and our network helps, and knowing a lot of you in this meetups really helps to associate them with our startups. And then, of course, during the launch stage, to go to Series A funding, there's the fact that a lot of risk reduction has been done by good validation and good testimonials from prospective customers really helps them to raise the value of their initial idea and de-risk it. And then the funding channel gets activated, and they see Fabric as a pipeline to providing such good startups that they have more trust in and want to invest in. So, and we of course try to reduce any missteps, and you cannot guarantee success, but you can improve the probability of success by avoiding missteps and de-risking the project. So that's what we do, and we do it not alone, but we have a center in India where the development work can be done, bootstrapped for the startups, and they can build a team there if that's what they want to do. It's not mandatory, but that's a good start for them. And then we have strategic partners as well who have invested in our fund or in these companies. And then financially, of course, we have financial investors, and there's a whole range of logos I could point to here. So that's what Fabric does. If any of you are entrepreneurs looking with ideas that want to launch your companies and are in this space of cloud infrastructure, please reach out to Rajan, Prabakar, myself. We're happy to hear, and we will happily see if there's a model for us to work with you. We're always looking for fresh ideas at the very early stage, where a lot of validation needs to be done as well. So with that, I think, and of course this defines the spaces that we look at, which is basically huge billion-dollar markets where there is a major shift happening to the cloud and industrial IoT, and then our future, we are looking for things in the blockchain space, but also data-driven analytics space. So these are major trends that we track, but are well known to all of you in the industry as well. But this is our focus. So we're not trying to create the next Airbnb or the next Lyft, but our focus is in the cloud infrastructure space. Anyway, now I want to get to the main point. So today we have a great set of speakers that we have put together for a very important topic around the security and compliance issues of moving applications to the cloud. So to start that out, I would like to introduce Prabakar Sundarrajan, our CSO of Fabric, who is going to bring on the rest of the panel and introduce them. Thank you.
Thank you. Welcome everybody. So welcome to the 420 event. I don't know how many of you know the significance of 420. To mark the legalization, we have infused the food and drink there with something special. So if you feel a little tipsy, some people ask me, what is this hybrid security compliance? Like if I go park my Ford Fusion in the car, slot reserved for electric vehicle, am I in non-compliance? Where I have a Tesla, so I'm in total compliance, I am covered. I don't know about you guys. So anyway, NBA playoffs are going on. So if you want to know the score, Prem has agreed to live stream the scores behind me. So just please pay close attention to the speakers, they will be covering. So without further ado, I would like to invite the panel to come up here and take their place. I'm not going to spend a lot of time introducing each of them because I would like to just hand it over to them to introduce themselves for a minute and kind of bring their viewpoint about the topic at hand for a minute. Just go around and introduce themselves. And once we go finish with that, then we will get rolling on the actual topic. So we'll first have Vijay, Vijay's customer voice is from Visa. And then we'll hear about the perspectives of other people here as we cycle through other topics. So without ado, let me turn it over to Vijay to introduce himself, and then we'll take turns introducing.
So I'm Vijay, I'm from Visa, and I run the innovation group, which works on the future of payments.
Until recently, I'm Janga Aliminati. Until recently, I used to work for Visa as a chief architect to build a private cloud and also covered the roadmap. And I was with Oracle almost 15 years, playing very variety of roles, starting from consulting organization to middleware, and then I became an architect for Oracle Public Cloud. And I built the Oracle Public Cloud, and then I also moved the Oracle middleware into the public cloud. So I spend my time both sides of the fence.
No, two people from Visa, no ganging up on the rest of us, okay?
The mic
So
closer to your.
No, I'll share the mic.
Yeah, hold the mic closer to the mouth.
Okay, so my name is Gaurav Banga. I am the CEO and founder of a cybersecurity company still in stealth mode. We've been in stealth mode for about 18 months and we're just readying a launch. So more about that in a few months, a few weeks. Previously, I was the CEO and co-founder of a company called Banga, also in the cybersecurity space, which I ran for just a little bit over 5 years, and we accumulated over 150 of the Fortune 500 customers. So, and then before that, I've been in the consumer space as well as in the PC market. So I've done 2 companies before that in the last decade before, both of them in the consumer space. And I started my career as a storage engineer, software engineer at NetApp.
I'm Dave Larson. I have a tremor, so I apologize for that if the microphone is shaking. I am the Chief Technologist of Networking and Security at Hewlett Packard Enterprise for their software-defined cloud group. I've been in this role for about 4 months now. Previously, I was CTO and COO of a carrier-grade DDoS mitigation company called Carrera Network Security. And prior to that, I was at HPE, so I'm a returner to HPE. I was the CTO for HPE Networking for a little while, and I came into that through the acquisition of 3Com, where I ran product strategy for Tipping Point. I've been in the Ethernet and security market my entire career for 25 years, and looking forward to this conversation with you folks tonight.
Thank you. So let's just get rolling. So as I was saying earlier, Vijay is here from Visa. We wanted to hear his perspective from a customer standpoint on what the topic here, which is security and compliance from a cloud, how he sees that, and his experiences that should set the tone for the rest of us to have a very in-depth discussion about his thoughts on what are the needs, what are the problems that people face. It'll be very interesting to hear from Vijay.
So great, I'm gonna go for the mic. So first of all, there's seats here in the front if you guys want to come up, but they cost extra, right? All right, I'm just going to stand for a minute. Does this work? Can everybody hear? So I'm from Visa, and how many people here have an American Express card? Go to the back of the room and you can hear me.
Visa people get back to the front.
It's okay, we like to have competition. So a couple of notes about Visa, just get you guys warmed up a little bit, ask you some questions. Anybody know how many cards that we have issued, outstanding, ready to be used at any point in time? Guesses from the audience? 10 billion?
2 billion.
2 billion. Well, there's only like 6 billion people on the planet.
But they have multiple Visa cards.
Yes, they do, but not in every country. Well, okay, so you're too high, you're too low, it's about 3 billion, all right? So any idea how much the payment volume is that we transact every year, annually, annualized? 1 trillion?
2.
2? 10. Okay, now there's people arbitraging this. We published in our last quarter $8 trillion. So that is the payment volume. And then we hit about 44 million merchants. So it's a very large network. It's systemic to most economies. And in the US alone, we do about $2 trillion of payment volume. All right. So the brand attributes of Visa are trust, reliability, security, and convenience. And so for the folks that are working in security, like the first 3 of the 4 are all about trust, security, reliability, and of course convenience is critical. I want to just talk a little bit about innovation quickly as we do the intro here, because I run an innovation group. And really the problem that most large financial services companies face today is a problem of lack of innovation, right? Are there any great innovations that any of you have seen recently from your bank that has really turned you on? Anybody want to put their hand up? No, there are too many, you're too embarrassed.
Not too recent, after the online access.
So one of the issues that the financial services industry is facing is this notion of innovation. And when we studied this, we saw that the average product life cycle in financial services for a new product is about 4 to 6 years. Okay? It takes about 4 to 6 years to introduce a new product into the market. And when we started to look at how new innovations that are driving our business around e-commerce and mobile commerce, the cycle time is about 18 months. So to just give you a sense of how fast this is happening, anybody here ever heard of Square or used Square? You guys all know Square, right? They put a little dongle in your iPhone and they turn it into a point-of-sale device. And we love that business at Visa. We are a founding investor in Square. And we brought JP Morgan Chase into Square so that they could become the underwriter of the transactions. Square went from 0 to $14 billion of payment volume in about 2 years, right? And that's just massive growth. Last quarter, they reported over $14 billion in the quarter. So they're a top 5 merchant in the US now. And they aggregate lots of micro merchants, and it's all done through essentially developing a software stack on the edge of the existing infrastructure. Right? You just put the dongle in your phone, you download the app, and they're using all of the legacy infrastructure behind that. So one of the things that we try to do in the innovation group at Visa is we try to change the way that products are developed inside large financial institutions. The traditional approach of 4 to 6 years is just too slow. And it also leads to a problem that we call the too big to fail syndrome. Anybody here actually work in a large company or worked in a large company before? A couple of people, right? Typically, like the product development lifecycle works like this. You come up with an idea, you have an epiphany. Often it happens in the shower or walking down the street. and then what is the first thing you do? You go back to your desk in your office, and you write it up in a business plan, right? And your office usually gives you get a toolkit, it's called Microsoft Office. You ever heard of it? It's got Excel, PowerPoint, and Word. If you're fast, you spend about 6 months writing this up in a big document, then you go to your CFO, you ratchet the projections up a little bit, because you really don't know how big the market is, you don't know if it's going to be successful, maybe you exaggerate. And then finally you get the ROI calculation done, CFO likes it, you get budget, 6 months have gone past, and then you get to this thing, if anybody here understands what I'm talking about, you get to something called fiscal year budgeting window. Have you guys ever heard of that?
Yep.
It's how you get money in a corporation, right? And if you miss the window, you got to wait another year to go by, right? So even just your idea, writing it out, and then getting it through the budgeting cycle can take 18 to 24 months. If you're fast, if the epiphany happened on the day, 6 months before the window closed, you got it in 6 months. And then you go to your IT department, and what do they usually say when you come with a new idea? Has anybody ever experienced that? So you go like, oh, Vijay, thank you so much. We were just sitting around waiting for your brilliant idea, dying to work on your great idea, And instead what they usually do is they never say no. They have a very special way of saying no. How many guys are actually, people in this room work in the IT delivery side of the world? And how many people are in the demand side, like they're asking things to be built? Right, so it's like a mixture. So I'm usually on the requesting side because I need things to be built. And I learned that they never say no, they just have this one sentence, and it goes like this: let me size that for you. Right, have you ever heard that? And then they come back with a sizing estimate. It's on average 10,000 quadrillion, million, quadrillion man hours, just in general. Because they sort of think under their breath that'll keep them busy, and just give them some massive estimate, go and get your $10 billion in budget. So the whole cycle kind of just breaks down, and that's really why we don't get much innovation out of, legacy enterprise. And the reason why I bring this up is because in the whole notion of cloud computing, that's changed the game, right? How did Square get so fast? They went to AWS. How did Uber build their app? 80% of the code in the Uber app they didn't write. They didn't write the maps. Google mapped the world, turned it into an API call, has a monetization model. Braintree does their credit card processing. Twilio does their customer service. And they're able to build an application in a very rapid fashion using APIs, going to GitHub and what have you. And so what we do at Visa in the Innovation Group is we bring that rapid prototyping into the corporate world. And so we do things like human-centered design, design thinking, we solving problems for consumers, and everything is based on cloud infrastructure. And it works great for prototypes, and it even works fantastically for pilots. And where it kind of dies is when you hand the pilot over to the guy in the enterprise scale division, and then they start coming up with 1,000 reasons why this can't work, it's dangerous, compliance, it's going to crash, right? And so this is the real dilemma that we have. Corporate America has now progressed that we can use the same tools the startups have. We can build lots of pilots, prototypes, we can test things out, but we have a tough time deploying it at enterprise scale. And that's really like the problem that I would hope that folks here would try to solve, all the companies that you've invested in. And the issues are kind of like, I've come up with 4 buckets of why is it so hard to take something that was built in the cloud, you've prototyped it, you've tested it, maybe with 200 customers, maybe $200,000 of transaction volumes, low amounts of money that's not going to break anything, and then you hand it over. And the first problem is not technological, it's cultural, right? I used to run a business at Visa called CyberSource. It does e-commerce payment management, and sometimes we had outages, and I'd go to the IT infrastructure folks, and I'd say, hey, our system was down. They go, no, we were up. Some other pop on the internet was down. We were up, everything inside our firewall was good. We're 99.99% availability. And so this cultural notion of IP-based software delivery is not in the minds of people that run data centers. So that's a cultural notion that wherever the consumer opens their phone, hits the app, and has to get to your server and then pop all the way back, all those hops, that's basically your SLA. And you can't hide behind this notion of, my data center was up, but something in the internet broke, right? So cultural is a huge issue. The second one is this notion of an SLA. Most of the data folks in financial services run on an SLA, an uptime SLA, and they're worried about what happens if something in the chain of the startup that runs on top of AWS, that used Heroku, which also runs on AWS, breaks. What net can I choke? Who can I go after? And they get very nervous about that. I think AWS had an outage 3 or 4 weeks ago. and like Netflix stopped working, and half of the internet I mean, I take something in San Francisco to work called Chariot. It's an app-based van pool. The Chariot bus service stopped working because AWS was down. So this notion of the SLA enforceability is really a big barrier for enterprises. And then, of course, PII and regulatory concerns. You know, personal information, where is it stored? Can people hack into it? It freaks people out. And if you look at like the decision matrix of a financial services person, financial services is not like social networking. You know, if your Facebook feed misses a picture, you scroll down and the picture pops up. Or your Twitter feed loses a feed and then you kind of refresh it and it comes back. In money, we can't do this. Financial services, you can't lose a cent, because if you're 2 cents under reconciliation, you could have been $1 million on one side of the balance sheet and $1 million and 2 cents on the other side. So we have to be exact. And that really also scares people. And remember that because financial services is money, and we live in a democracy, governments are very worried about people's money because they don't get reelected if money is lost. So we have a lot of regulation, and if you look at how the CIO actually thinks of their mindset, they get fired if there's a breach, they get fired if there's downtime, but they get no credit if the system runs stable or if a new innovation comes to market. So they're always going to solve for no downtime, no data breaches, right? And in the last few years, there have been quite a few publicized data breaches from very large retailers. And what has happened in most of those, the CEO has been fired, right? Not just the CIO, but the CEO has been swapped out. So when you guys are developing cloud-based infrastructure, these are the sort of things that maybe would be really helpful to have in mind. And with that, I would say that's our intro from an enterprise side in terms of the things that we're worried about.
Awesome, thank you. So I think you made a few key points in terms of what you're looking for is the agility, the reliability, and the performance. So I would like to kind of maybe have the people take turns, kind of maybe answering a couple of those points, and then we'll get to additional topics.
Yeah, I would like to add 2 data points. So, especially technology shift in the cloud is changing a lot of dynamics. For example, at Oracle, when we tried to build the infrastructure, cloud infrastructure, it took us almost 1.5 years. And then when we tried to build the first cloud service, it took us almost 8 months. Because any cloud service that you need to build, it requires orchestration engine. So that needs to understand your onboarding application requirements. So because of that reason, enforcing compliance and also adapting multiple clouds, it's very hard. After moving to Visa, we built similarly infrastructure on OpenStack. It took us almost 6 months to build the infrastructure. Because we need a virtualization at the VM level, network level, storage level, and then when you try to bring in application, your orchestration engine need to understand your application requirements. So that was kind of a barrier to have a proper segmented rules and also to adopt the clouds and the multi-cloud adoption. But the technology shift, for example, nowadays every new development is adopting cloud native development model where customer can containerize their application stack. Once they containerize, they can roll it in any platform, container platform. For example, in Visa, to build a private cloud, it took us 6 to 8 months with 30 to 40 people. But to build the container-based PaaS platform within 8 resources, probably in a couple of months, we were able to build the platform and address exactly the same requirements. So because of that reason, what's happening is multi-cloud is become so easy, and compliance and security become essential because you're doing multiple clouds and you have to have a harmonized fashion or automated fashion to push your compliance requirements.
Thanks for the additional perspective, Janga. So, do you have any comments on the needs here?
So I think it is instructive to look at concerns along 2 different dimensions. One of them is the concern around compliance. Compliance is not security, right? We all know that, we should know that. Nevertheless, compliance is a big concern. And when you're building products, particularly when you look at a startup company or even a group of people inside a large company that are building a new innovative product using cloud-native technology, perhaps even multiple cloud-native technologies, perhaps using the latest and greatest Docker, containers, and so on and so forth, talking SDN and everything. What they don't have in their mind and what they don't think about too much is compliance. They don't have a model of compliance. And if you are targeting financial services, I think that's a mistake. You should think about it from day one. And you should, the compliance is not going to be automatic. The compliance is, like for example, if anybody has gone through a PCI compliance exercise, you know how hair pulling it can be. You can spend $500,000 in a few months just trying to prove to other people that what you say is working is working. But compliance is not security. Now, on security, I think it is instructive to think in terms of the broadest definition of security, which is not just confidentiality as what we like to think. It is integrity, it is confidentiality, and it is availability. And that is the full definition of security. And if you can think about security from those terms, from your first architectural design diagram. So for example, if AWS is one big block, there is some correlation between failures of AWS East and failures of AWS West. And if you ignore that correlation, that's like building a RAID system, assuming that two disks connected to the same power supply are not correlated to each other. Right now, the connection in AWS is not the power supply, but it is something else. It's a common code base. So if you want to build a truly redundant, available system, which financial services requires, before you can get into large-scale production, then you're going to have to worry about availability, just like you worry about confidentiality and integrity.
Microsoft thanks you. Microsoft thanks you.
Thank you.
So he said, don't just use AWS, also use Azure. No.
And Google Cloud.
And Google.
Your own cloud.
And your own cloud. Okay, all right.
More importantly, you have to think about this when you're designing it, right? So if you want to use, for example, containers, well, then you still have to think about availability. Containers automatically not going to give you availability.
Great, thanks. So, Dave, with you, I think if you can take a minute to just get your thoughts on what Vijay said, and then we'll come to a key topic that I want to have you address. So maybe just take a minute for reaction to Vijay's thoughts.
So I think the point about compliance is the thing that resonates with me. It's not the same as security, and the more interesting thing about it is a false sense of security. You may be compliant, but you're almost certainly compromised at the same time, and you may actually be breached. And the financial community has seen this many times. So for me, the real thing that that allows, or from the innovation community, from the entrepreneurial community, the startup community, the thing we need is a better way to truly visualize our security posture in a very distributed way. So you might think, oh, I want to go and I want to build cloud security, right? Because it's a giant, there are huge economic drivers that are requiring people to move to the cloud. It's not just a desire. They need to get there. They need to be competitive. They need the cloud to do it, but they need to be secure. And what you find is that they compromise in order to do it. Maybe the financials don't, but other folks do.
So that's very interesting that you mentioned that. That brings me to my question for you, which from your previous background and what you have been up to, it seems like there is, just from what you just said, people have to think deeply about what security means with respect to the cloud, right? What is it? So what are the different components in your viewpoint, and how should people be thinking about the different pieces of security when it comes to the cloud?
They need to think about it at a higher level of abstraction. If you talk to a typical enterprise security person, they're going to talk to you about their defense in depth strategy. They're going to talk about the edge. They're going to talk about firewalls and intrusion prevention and data leak prevention and WAPs and you name it. And then they're going to say, I have been mandated to do this by my compliance obligations. Right? PCI DSS is going to tell you that you need all of these things. And then I want to move my workloads into the cloud. So what am I going to do? Am I going to put a virtualized stack next to every single piece of my workload in the cloud and achieve parity? No, because it's going to cost you a fortune. You won't get the economics of cloud if you have to do that, because the security applications themselves, all of those layers, will cost more than just running it in a private environment. And that's what we're seeing people looking at. When they look at the economics of cloud, it looks really good at first because their dev test environment has been roguely outsourcing IT for a while, and they're out there and it looks really cheap. But then they bring it inside, as Vijay mentioned, and they bring it to the IT team and say, let's productize this. And then they hold up all the barriers that are there. For me, I think that the community needs to look at the security problem as one of identification from a visualization standpoint and true composable authentication. Every application has various components. They can all be co-resident on a server. They can be distributed in a multi-cloud fashion. They need to be able to be reliably authenticated together so that nothing else can get in. And today's security stack doesn't envision that. It envisions putting a gateway between what wants to talk to the application and then trying to derive the intent in order to stop something that's bad. You all know this, it's full of tremendous amount of false positives. So what do? They back off the security policy in the interest of allowing transactions to take place. They are still compliant, but they're not secure. And cloud totally makes that model a bigger concern. One other point that I wanted to make, and we don't need to go down this as a tangent, is if you're thinking about getting into cloud security, don't think about that as the only option for distributed security. I've been mentioning in conversations with folks in the room tonight, and I do this everywhere I go, cloud security is almost identical to mobility security and IoT security. All of it is about distributing these small elements, whether it's a workload or it's a smartphone, a tablet, or a sensor. All of them require some overarching ability to view the environment and to be able to attest to its posture. So this is not just cloud security. They're gigantic markets that need this kind of control. And so if somebody can generalize this, it will be applicable across all of those spheres, because frankly, all of them are cloud in one way or the other.
Great, thanks for those comments. Any quick
Can I just
rejoinders?
Is this thing on? So I'm feeling like I'm flying at 80,000 feet and I don't understand all the components down at the level that you guys are building the building blocks. But I think that there needs to be a complete paradigm shift, because like even when I heard Dave, when you were talking about the application, the way we think about building applications now is we're actually disaggregating our product stack. So like, I'll give you a concrete example of Visa. We don't have a lot of products, but we have a credit card, a debit card, a commercial card, and a few other products. And in the past, what we would do is you say, we have a credit card product, you want to be a bank, you want to issue one of these cards, you sign up to the full product stack. The product actually looks pretty well the same to just about everybody. It's actually a bunch of messages going back and forth. Now we're getting to a stage where we are disaggregating the components in the stack so that our banks, for example, can come up with new use cases for cards that we've never thought of. I'll give you a concrete example of a really interesting startup in Oakland, in the Bay Area, called Marqeta. They have become an issuer processor. They allow any software developer to become the issuer of a credit card using API calls. So DoorDash, if you guys know them, door delivery company, they deliver food. They came up with a use case that we never would have dreamt of if we had our fixed stack paradigm, and it was that the delivery guy going to the restaurant has a virtual card, a piece of plastic in their pocket. When they go into the restaurant, the phone geolocates them in that restaurant, and the card is turned on in the cloud only for that restaurant for the amount of that order, so they can swipe it, pay the money, and then walk out of the restaurant, the card's shut off. Now for us at Visa, we have a very big, distinct species barrier. We think of merchants who accept cards, and we think of issuers who issue cards and the consumers have the card in their pocket. This startup, by just disaggregating the product stack into components, has blurred that whole line. The merchant is the issuer of the card, right? And is turning it on and off. And so our goal in terms of trying to harness what we call the power of the platform, or the billions of IQ points that don't work for us, is to let developers go wild with their ideas. And the power of the platform is, best illustrated by iOS. There's like 2 million apps in the App Store. The phone ships with like 8 apps from Apple, and all the other apps are developed by other third parties. And that's what we're trying to do. So we've launched something called Visa Developer Platform. It's a set of APIs, it's a sandbox, RESTful APIs, documentation. And so when you guys think about security, and I don't have the solution for this, more of a challenge. How do you let third parties stitch together multiple components and deliver it in their service, which is not going to be top to bottom, single app, single delivery?
That's a very interesting perspective. Disaggregating security itself, that is something, and also composing it out of multiple different components, which is a point that you also made. So that is awesome. So I think in the interest of time, we will move on to another topic. So Gaurav, I would turn it over to you. In terms of getting a different perspective, Dave talked about this issue of distributed security and access security and all of those kinds of things. From your standpoint, what about the application? You mentioned this a little time ago. Application running on the cloud, what kind of security can it expect from the environment itself? And that's one aspect of it from an IaaS, PaaS perspective. And then we hear a lot about SaaS and what security mean for that, and what do cloud access security brokers do for that, and things like that. From your experience, can you comment on a couple of those kind of issues?
So this answer is not going to surprise some of you, but it will. So the way you want to think about security is the adversary, the bad guys, whoever wants to compromise you, they will look for the easiest way in. Right? And actually this might be counterintuitive, but the infrastructure that Microsoft, Amazon, and Google have is way secure on its own than almost any data center that any enterprise can build, with some exceptions. Right? Clearly the average Joe who has a $1 billion company that just went public is nowhere close to the kind of security that investment that Google, Microsoft, and Amazon have done into there. So the biggest weakest link in the beginning is what you introduce when you implement your application. They don't help you with compliance because Amazon can easily look inside your infrastructure if they wanted to, and that breaks compliance because the chain of control is with a trusted third party, and you need an SLA from them and so on and so forth. Which they are happy to provide, by the way, if you just ask. They just charge you a little bit extra money. But this is counterintuitive, right? So what you're really saying is you're responsible for your own security because you're introducing insecurity the moment you start using AWS or Azure. You open a single port with some protocol and game's over. Now it is no longer the pristine Amazon environment. This is your application. It probably has more bugs, security bugs, and it doesn't matter.
No, bugs? No way.
Yeah, no way. Then the infrastructure has. To beat the infrastructure is much, much, much harder. I'm not saying it cannot be done. It has been done, but it's not your biggest problem. So this is the counterintuitive thought that you want to think about. The only other counterintuitive thought I'd like to offer is security is end-to-end, right? And the adversary will again go after the weakest link. So if you're composing, a slice of a stack, which you should think of your stack as starting at your client endpoint. That could be a point-of-sale device. It could be Square running on an iPhone, and then it is the transaction, the network that is happening, and then finally it's your application running in the cloud. And again, if you look at it, the two weak points over there are, generally speaking, the endpoint. To go into and try to hack Comcast and Visa, Comcast and AT&T's mobile network, it's certainly possible. But that's not your weakest link. Your weakest link is going to be either that shortcut that you took in the application in the cloud, or that shortcut you took in the application on the endpoint. And that's just a counterintuitive way to think about it. It's like, don't worry about Amazon, Microsoft, worry about your own stuff. And that's where it becomes very hard.
So, Janga or Vijay, any from your prior customer experiences, any thoughts on what Gaurav and Dave mentioned?
Quick data point. So, even the private cloud or public cloud, some of the providers mainly concentrate on perimeter zone security, right? They try to implement perimeter zones so secure so that they think nothing could happen to their internal systems. But I mean, what's happening in today's world? If you look at recent, attacks, attacker can enter into as a real user. So they can get the username password through phishing or some other means. They can get into the system as a real user, and then they can penetrate deeply into your system and do whatever the attack they can do, right? So it's very important to not only, apart from the perimeter zone security, you have to have a system to withstand these kind of attacks, right? Internal systems. And sometimes sometimes you can't prevent, but at least you can minimize the risk by giving a proper training to your users. Like phishing is simple, use case, right? You can get an email, you can click it, and it will ask something as if you're opening your own application. Especially the training is needed for executives. Most of the executives, even recent DNA, during your elections. So what happens? Through phishing.
Are you about anybody in particular?
I don't want to give the name. But they were able to provide their username and password for whoever attacked through phishing, and they were able to attack the whole system, and they were able to manipulate the whole election system. So it's important to withstand proper measures to withstand the system for all kinds of these attacks.
Is there any additional thoughts?
Yeah, I just wanted to just go back to an earlier thread, which is, this disaggregation of the product stack, and you guys delivering us infrastructure that can allow us to deal with this weakest link of the chain issue without us having to think about it when we're coming up with solutions. You kind of just take care of it. It's not only happening because of the innovation imperative, because people want better consumer experiences, and it used to be that you would judge your consumer experience maybe at your bank differently than you would on some app that you have on your phone. But today people will judge everything at the same service level. So that innovation imperative is just pushed harder and harder. But it's also coming from the regulatory side, and I just wanted to throw this out there. Has anybody heard of something called Payment Service Directive 2 in the United Kingdom, PSD2? If you work in financial services, it's really important. So, in fact, if you want to know about the future of financial services and disruption, you study China and the UK, because those are the two leading markets. In China, financial services has completely been infiltrated by Alibaba, Alipay, Tencent, WeChat, WePay, you name it. And in the UK, the government is legislating innovation by forcing something called open banking. So they are forcing banks with a deadline to open up their system so that third parties, could be a startup, could be a fintech, can gain access to the information stored in the banking system. And it's legislated by law that the banks have to have open APIs that allow a third party to get to, let's say for example, I have a bank account at Barclays UK. A third party has to be able to have access to my bank account, of course with the consent of the consumer, so that they can come up with new applications that deliver a better consumer experience for the UK banking consumer. So this stuff is really, really important, and it's being on the one side of the ocean legislated by the government, and in this country it's more driven by innovation. So I just wanted to throw that out there because the notion of disaggregation and opening up the systems is important. And when you ask the banks, what are they mostly worried about with PSD2? I used to think they would say, we're worried about the innovation. The fintechs are going to take us over because the government is opening up our system. But what they say, in 99 out of 100 surveys, we're worried about cyber.
It's very interesting. A lot of times regulations are there to restrict things. And these are a couple of scenarios where they are opening things up. And by opening things up, yes, they are opening things up to the cyber kind of things. Dave, any comments on what Gaurav had to say?
Yeah, I think the reason that I harp on visualization and the disaggregation of the stack, right, is that I want to see another disaggregation of another stack, and that is the defense and depth stack. And there's a reason for it. You have to have, in order to actually be effective as a security professional, you have to basically have a PhD in a very narrow field. So I'll be a firewall specialist, I'll be an intrusion specialist, I'll be a DLP, I'll be a SIM analytics, deep analytics person. Yep. The reality of it is that when we disaggregate the stack, we create one other problem for ourselves, which is this. When we first started trying to understand the vulnerability of a given application, We would deploy that application on the server, and we would surround it with a bunch of scanning tools and penetration testing capability, and we would find out, oh, it's got this little vulnerability, we need a patch, we need a workaround, we need to fix it. When you deploy a disaggregating stack into the cloud, you now have to test that scanning capability against every component of the stack. And now you have an entirely different data security problem in terms of encryption. Do you really want to add that in at every layer? Because you can never figure out whether or not this was an authenticated conversation. The reality of it is that we have this notion of a gateway that sits in front of everything, and we think it's going to keep us safe. In reality, we have 10 gateways that we now stack up in front of, particularly in the financial services environment, and guess what that is? That is unnecessary complexity, and it breeds opportunity. There are seams in that environment that can actually be exploited against itself for the breach of the environment. The infrastructure is actually inherently unsecure, and there's a gigantic economic incentive to learn how to exploit that. So you see, simple things like, I talk about the Amazon goes down, but the Friday before the US election, the entire East Coast went down. And you know where it went down from? A botnet attacking a DNS provider. It didn't attack Twitter, it didn't attack Okta, it didn't attack Reddit, it attacked Dime. And it brought the entire internet to a standstill because that was one layer. It's not the only layer, it's one nice ubiquitous one that is wildly not secure. But this whole notion that we can somehow get in the path and solve the problem is being proven to no longer be viable. So the entrepreneurial startup community needs to find ways to fix this disaggregated thing with something that is, provable, attestable security.
And just to add to that, that's where I think we need a paradigm shift.
Yes.
Because the paradigm of the CIO is, I'm going to choose what applications the employees in my company use. All right, and then I'm going to protect them at the front door, and the bad guys can't get in, and everything's good. And we use Chromium, and we use all this stuff at Visa, and you see it every time your Dell laptop boots up. But one of the things that we notice, myself running an innovation group, we tell our employees to be innovative. And it used to be 20 years ago when you worked in a corporation, you came to work on Monday morning, and you had the most latest and greatest technology that nobody could afford in the home. And today, when you come to work on Monday morning, you go in a time machine. The time machine takes you back 20 years. You're using a version of Windows that came out the year the iPhone came out, and they're having their 10-year anniversary, which takes 6 minutes to boot up on a Dell laptop. And then you go to lunch, you leave the building, you pull out your smartphone, you pay with a scan code, you have full internet access, you check your Facebook feed, and then you go back 20 years into the past when you get to your desk again. And that's because the CIO has this paradigm that's just broken. People choose the apps they want to use on the phone, on the supercomputer in their pocket. And that to me is just a metaphor for when we build apps, the paradigm is just so woefully broken.
Yes.
So Gaurav wants to say
Yeah, so
something.
one thing, you both asked the same question, which is what's the paradigm shift? And I'd like to offer this, right? So let's look at that chair.
Okay,
Right?
I'm looking.
That one chair, and you're sitting on it. That. So when you look at that chair, who is going to complain what would happen to the chair when an elephant is supposed to sit on it? It'll break, guaranteed. Or even a 500-pound man, if there is such a thing, right? So bridges, right? So bridges are designed. Do you think the Golden Gate Bridge would fall down if 5 or 15 or 200 of those ropes were to break? The answer is no, it won't. So in almost every other area of design, when we put things together, the designers, the engineers, they have to pass an exam, and they have to go through an education system that teaches them this, that you are operating under a threat model, understand your threat model. Engineers I've known, my wife was one, civil engineering, she would multiply everything by 4, right? Rule of thumb, right? The wind velocity will never exceed 4 times 200 miles an hour. That was in Houston, right? So when you do things like this, you train your mind in your design process to say, everything is breakable under a certain load, and I can put 2 things in series, 2 things in parallel. Now, defense in depth is kind of like that, but done without any thought process into it. And defense in depth is like, okay, well, I'll leave the biggest circuit in parallel, where you can go, there's a backdoor over here, but I will pretend that I have forward. And by the way, I don't need something over there. So the trick to this is start thinking of every one of these components as components that can fail. Start thinking of even AWS, bigger they are, the harder they will fail. And when it fails, then let's have a plan of what is it that you will do to recover. Now, this is a different kind of design thinking which is essential to success in security. And compliance comes after that. In fact, one of the compliance rules would be to use it to that thing.
So, yeah, I do want to come to compliance, which I would like to have Janga talk about a little bit, and then we can take turns. But before then, I think we talked about kind of like the customer viewpoint and a couple of different views on security and the rejoinder. So I would like to get a couple of questions first from the audience on this aspect of it, on the enterprise needs and how people are thinking about security. Go ahead. We don't have microphones. Sorry. You got to speak up.
Janga, let me
Can
have
you
that.
stand up and speak up? That's fine.
That's too much, though.
I've got a mic runner now.
I'll try my best.
I'll try my best.
You're always a good show.
Please introduce yourself.
Well, that's it. So I will, first of all, I appreciate the, conversation you are having. I've been in the technology industry for a number of years, and I've seen security problem being discussed with the same vigor for the last 20 years. Seen a lot of companies go public, seen a lot of issues, discussed, but the problem seems to continue to keep growing, continues to grow. And today, what brings us together, obviously, is a good deal of discussion on cloud. And so I have one, cloud is a huge issue today. Cloud has become massive. But there's only one stumbling block, and that is the notion of security. And where do you go to discuss, solve the problem? Do you touch the operating system? Do you work on the communications link? Do you work on the switches? Do you work on the firewalls, intrusion detection? Everything is broken. Everything has problems. So the question I have for you is, particularly those people who have been in Visa and who have handled customers, do you understand the man-in-the-middle requirements well? Do you encounter man in the middle? Do you think man in the middle could be a big problem for cloud going forward? That's.
A man in the middle in general is.
Do you understand? Is it a relevant question?
Yeah. So, man in the middle in general is a security problem that most people understand well, and especially things like the SSL protocol, etc., were devised with that in mind. But nevertheless, since you asked the question, Vijay and Janga being from Oracle and Visa, so maybe you can take that question in terms of from a more general standpoint, not just man in the middle. How do you think about addressing this point that security has been talked about to death, but still we are having problems?
So, so first of all, the man in the middle problem is, it's like hundreds of men in the middle because the average person has 100 apps on their phone. So, now you have a lot more entry points. So it's a real issue. And one of the things that we're trying to do a lot around is biometrics. And biometrics are, on the one hand, for convenience, but on the other hand, they can be more secure. I know I've got some real security experts here, and they'll tell me how you can, fake the fingerprint and all that. But the reality is, biometrics is going to be a way, we think, to authenticate the user. And we have a point-of-sale system, for example, in the innovation lab from a company called Morpho. And you touch your finger, that's all it is. The whole point-of-sale device is just a fingerprint reader. There's no card slot, there's no printout, it's just you touch your finger, and it has what's called vein pattern recognition in it. So if you want to be Tom Cruise in Minority Report and chop somebody's finger off, and then take their finger and authenticate the transaction that way, it won't work because it looks for blood flow in a living hand, okay? So biometrics is an area that we think will be very helpful, and the new Samsung S8 has very, very fast biometric authentication with iris scan, and that'll be one way to get rid of man in the middle because you are the credential. And then this whole notion of having a username, password, or a piece of plastic in your pocket, and then somebody can, hijack that payload or those authentication credentials goes away because you become the credential. So that's one way that we're thinking about it. I don't know if the other panelists are working on that, but biometrics hopefully will be, a huge boon for us, and every smartphone has it built in.
So I wanted to comment on the one aspect that you mentioned is we've been talking about security for 15, 20, 25, 30. Actually, I am a Homo sapiens. I am descendant from the first human beings, Homo sapiens, which is 250 million years ago, 200 million years, no, 200,000 years ago, 175,000 years ago. And even they had a security problem. So one thing that you guys we should all, we are telescoping into cloud. In 1989, we were telescoping into the Morris worm, and we said, what a big deal, right? And 170,000 years ago, we were telescoping into the guy who's trying to steal the kill that I did. So security is going to be around with us for a long time. The one thing that is special, and this is not about cloud, it is about the internet in general. What the internet has done is, and there's an easy way to state it, war and crime have come online. Right? And so if you want to think about, these are the preferred places to conduct war and crime, because they are the economically highest value places for the adversary to conduct war and crime.
So I have a short comment, and then I won't take much of your time. This whole idea of startups and big corporations sitting in a room and trying to solve the problem is one aspect of it. And there is a persistent tension with the government agencies who want greater access to the security features you and I are trying to develop. Do you think that it is about time that corporate America, private companies, and government sit together and come to certain agreements that we can do these things so that it can be solved? You can write the best operating system, but tomorrow some agency may say, I need access because something really bad is going to happen, I have to stop.
Thank you, thanks for that comment. So I think we may have turned some kind of a corner on this, because in the recent Economist, they just basically said computer security is never fixable. People have to start thinking about insurance. Okay, so that's another way of thinking about this problem. So any other questions or
Can I just
comments?
say one more thing about
Yeah.
the security issue? Because the reality is, I like Gaurav's comment of we've had the security problem since, you're trying to steal the kill. But it's phenomenal in payments that we've gone from, $2 trillion of payment volume to $8 trillion in the last 4 or 5 years, and the percentage of fraud is static, right? Like we've done 4x growth on dollars processed on our network, and the percentage of fraud is absolutely static. So we've actually been pretty good, at least in payments, on coming up with algorithms that can score transactions in real time and use machine learning and neural nets and what have you. But there's a much bigger wave and tsunami about to hit us, and I know this is like the new trendy word, it'll change in 2 years, but it's IoT, right? I mean, we used to think at Visa, 3 billion cards is great. Let's get these 3 billion cards into the 4 billion smartphones, and then we're done. I think Bill Gates, 15 years ago at TiCon or something, he said something like his goal was a computer on every desktop. That was considered to be like the absolute, big, hairy, audacious goal. What a tiny market that was, right? With 7 billion phones in the world.
Slightly larger than the total of 5 computers in the entire world that Watson predicted.
I mean, but now 50 billion IoT devices, and to Gaurav's point about his wife who's civil engineer, my dad was civil engineer, there's only one Golden Gate Bridge, but in software we can make 10,000 crossings across, to Marin County. And the IoT is the collision of basically software hitting the physical world. Because in a self-driving car, you have a sensor, you have connectivity to the internet, you have a ton of software, but the car is going to have to brake in order to not kill the child that ran across in front of the car. So this whole notion of software hitting the actual real world, the explosion of it is way beyond the security issues that we think now. I mean, it really is life and death.
Yeah, so this brings me full circle to what I said previously, which was this giant distributed security model, which is being exampled here in IoT. It's about authentication, in my opinion, first and foremost, not exclusively, but you have to know what it is. this little endpoint, that there's going to be 100 billion of them or some insane number. In fact, the projections for the amount of IoT devices is clearly going to exceed what the analysts think it's going to be. All you have to do is look at the hockey stick. It's insane how it's growing. But you have to start at authentication, and I'm going to do a little bit of a commercial here from my friends in Aruba. They do a really good job of this with their ClearPass environment, and they take it from an endpoint position inside the enterprise, and they begin to solve that problem. Now, that doesn't solve the whole problem. We're now in cloud. How do you apply that to cloud? You need to be able to authenticate every single workload, every container, every VM, every device, anything that is in the chain of communication. So it can't just stop at I allowed this on the network. It has to be somehow imbued into the way we connect the stack of the application so that it knows that it's reliably communicating to something it's authorized to communicate to.
Excellent. So that actually brings me to the next topic I wanted to first have Janga address, which is that you talked about the complexity of these things. But actually, as people start to think about, I'm just going to have my data center, right? And then Oracle, you guys built your public cloud, and then Visa has a private cloud. So there are all these different environments, and then so you have the security problem in just one place that's so complex, and then you have to satisfy compliance on top of it in one place. What's your history and thought process on how this would apply to these different places that people are trying to utilize?
Yeah, it looks like your question is, more aligned to how the compliance is enforced across all the clouds.
Not just the compliance, also how you can be consistent. The security posture will be consistent, because solving it in one place itself is going to be so hard.
Exactly. So I think that's one of the interesting question, and recently I've been in many conferences everywhere, CIOs, CTOs talking about the compliance and security importance. So before I talk about how the compliance is enforced consistently across all the clouds, let me step back and look at it a little closer from the source. So if you look at today's customer data centers built over the years, maybe 5 years, 10 years, and different security controls and compliance policies are enforced as they find the issues and bugs. Now, if the customer wants to take that workload to cloud, any cloud, so they have to go back and read all the policies that they have enforced over the years. It may be like firewall policies, load balancer policies, or even IAM, DLP, IPS, IDS, and so on. So it's very complex. Even if you put so many resources and so much time, and even if you identify all the policies being enforced, and how do you assure yourself all the policies that you collected are complete comprehensive list to comply with HIPAA or PCI or whatever the vertical you need a compliance from. So I'll give you a quick example, a real world example. Recently I was working with a customer who has a 3-tier deployment, and they have applied all the compliance policies and they are being certified by all the auditing authorities. When I look at their environment closely, for the one single firewall control which says every communication across the firewall has to be encrypted. So it means the communication coming from end user to your DMZ or perimeter zone, and from there it goes to application tier and data tier. So they have smart admins, and they added proper firewall rules. For example, the request coming from the end user, they applied the firewall rules to allow only SSL and 443. From the web tier to our perimeter zone to application tier, they again added firewall rule to allow only SSL. When I look a little closer, the request coming from the end user is landing on the load balancer, and load balancer is forwarding to web server. So they have encrypted all the channels, but there is a channel from the load balancer to web server which is in the perimeter zone. They did not secure it because they going through only literally the rule, the PCI or HIPAA rule. So this is very serious gap, right? It breaks the compliance too. So what we need here is a system which can go to existing customer deployment, read all the compliance policies in an intelligent way, and map it to application, so that when customer try to move that application, it should able to come up with a comprehensive list. And also system should provide a standard template like HIPAA or PCI, so that customer will compare their identified controls with a standard template, so that they can see the gaps right away and they can fix it. So let's say they have identified all the compliance rules and fixed it. Now they have to take it to a cloud. Let's take a simple firewall rule, and they have to take it to AWS. So in the on-premise, they have a physical firewall like a Palo Alto network, or Palo Alto PAM firewall or Citrix firewall, and now they have to take it to AWS. They have to transform that rule into AWS segmentation. So they have to understand that. And if they take same firewall rule to Azure, they have to understand NSG policies, like network security groups. And if they go to Google, they have to understand SDN policies. So simple firewall rule, if they want to take it to any cloud, so they have to learn this. The another real world example I want to give you. So recently I was talking to a CIO conference where CTO from one of the automobile insurance company, they've been trying to move to their workload to cloud for last 1 year. So they have on-premise, firewall-based policies and a load balancer like F5, and they want to take those policies into AWS and Azure. They want to adopt multi-cloud, and they spent over the year, and they sent their engineers to Microsoft and AWS to learn things, but still they couldn't make any progress. So what we need here is, if you look at it, we need a system that should intelligently understand the existing policies, normalize it, transform into target cloud format and enforce it, so that customer doesn't need to go through this learning process or spend years together just to learn that and forget about adopting multi-cloud. And let's say once they implemented, once they have the application in the cloud, and now they need a visibility at the runtime environment. So they want to know how their application is doing. Are there any elevated access controls, or are there any rogue process running, or is there backup happening regularly, or is it successful, who is validating it, or if their backup at the rest as encrypted, or the data at the rest encrypted. They want to know exactly everything what happening in the cloud. But today I was talking to one of my friends who is a CIO of aerospace defense, and they try to move their applications. A year back they moved few applications. And after that they didn't move. I asked them, why you guys didn't move? So the way you replied me is, I don't have a freaking clue what's happening in the cloud. So they don't have a visibility, and because of that reason, they don't know what's happening, and they don't want to move their applications, sensitive applications. So what we need here is a system which could instrument and collect all the evidences and incidents, like whether the system is backed up regularly, or whether the data at rest is encrypted, or who is doing what. Everything the system need to collect and transform into auditable format and integrate with their on-premise dashboard like a Splunk or Kibana or RSA tools, RSA Archer kind of tools, so that customer can compare the data with their on-premise data, and they get continuous assurance on the compliance. They know exactly what's going on in the cloud, and they will be assured to move the rest of the application. So that is the way compliance need to be enforced with the multiple steps, so that customer gets always, they feel they have a continuous assurance on the compliance. And also, if they want any auditing requirement, they just print the report and give it to their auditors. They don't need to wait or prepare for the auditing.
So you're saying one of the ways to address the complexity is an intelligent system that understands the nature of these different things and homogenizes
Exactly.
and automates the thing. So any reactions to Janga's points, please?
Compliance is about being able to pass an audit, right? And that if you can't pass the audit, then you're in trouble. But in reality, in the cloud environment, just passing the audit is going to almost be a false sense of security, because there is no framework. They don't know how to audit it. They don't know how to tell. If you're putting information out there, how can you be assured there's no shadow copy of the data that's unencrypted? Just because you're following down through the stack and you say this is over here, well, maybe I took it with a root privileged process, and I moved it over here, and I stored it as a backup, and I forgot to encrypt it, but it's not clearly there in the chain from the operation of the application on a day-to-day basis, and you have no way of knowing. It's about doing inventory. Ultimately, the reason that I talk about authentication, think about it more as user behavior analytics combined with onboarding, but not just for users, right? You talked about biometrics as an identifier. What biometrics are you going to provide when the entity that you want to authenticate is a process that's running in a VPC in Amazon? What is it? It needs some kind of cryptographic unique identifier that allows it to be attestably known to be what it is. But this is all about finding a way to perform an onboarding capability of only authorized components to the entire stack. And then we start to become natively secure. We'll never be fully secure. Someone's going to have the financial incentive to find a way around it. But then, once you start getting there, you now have to start talking about credentialed misbehavior. And that's where the analytics comes into play. It might be a fully authenticated stack, every single component at every tier, all talking to each other. They get compromised by an account that is infected and is now operating this thing. So now you need analytics to see that it departed from the norm. And that's not user behavior analytics. That's component behavior analytics. It's pieces of database behavior analytics, or encryption behavior analytics. What is happening? Why all of a sudden there's all these key exchanges taking place in this environment when I don't authorize that? It's departure from the norm. So heuristics, machine learning, all of this matters, and there's a wealth of that capability here in Silicon Valley that we just need to bring to bear on the problem. And to do it in small pieces. If you try to do this in a monolithic way, you'll never get it done. But if you just solve a small piece of the problem that's around the database pieces that are deployed in the network, or it's around this particular network connector technology, if you solve something that is part of that kind of a fundamental philosophy, then we will be able to fix this as a community.
Thank you. Any other comments on Janga's comments about how to address the complexity of multiple things and then make it all uniform? Any other comments from the panelists? Okay, so I will again turn it over to the audience here. I can come down and then see if people have any questions. There is one question in the back here. Anybody said question here? Okay, we'll start with this one.
Yeah, my name is Sagar. I'm working on a virtual assistant for restaurants and bars called HostBuddy. So one of the automations is the payment processing. For example, when you're at a full-service restaurant, so the POS system is digital and you have a smartphone. So we go to the POS and we will show you the check, and then you can pay for it and then leave. So it is convenient and also more secure because you are paying through Apple Pay and through biometric authentications. When do you think this market is going to take off?
Which market?
The payment, in-app pay for an offline transaction. So think of it as an Amazon Go for restaurants.
Yeah, I mean, it's interesting that there was so much activity around Apple Pay that launched a couple of years ago, and everyone thought that it was to be a holy grail. Everyone would start paying with their phones. The take-up hasn't been really anywhere near anybody's expectations. It's been pretty low, actually. And so, this is the thing about consumer habits. Consumer habits are really hard to change. And the thing about a piece of plastic in your pocket is it's actually a pretty decent form factor. It seems to have much more legs on it than we thought. You can put your card in your jeans, put your jeans in the washing machine, take it out, it still works. Go underground, no battery. It doesn't need its connectivity to the network. So I think that to answer your question, it's more a behavioral change thing. And one of my personal opinions is until you can get rid of the wallet in your pocket that requires you to have a driver's license in it, then you're going to have a credit card with you, and then you're not going to be switching to your phone. And we've seen, like in places, Australia, Canada, where they have contactless cards, cards that have a RFID, NFC chip in them. People don't use the phone-based payment that much. It has taken off in China, however, with QR codes, and in India with ATM.
It's not even QR code. So through NFC, again, you had to match and you had to be by the payment terminal. I'm talking about in-app pay, because we looked up your bill from the POS system. If this table has this, and the consumer has a real pain. He wants to leave. Right now, the ritual is he has to take your card, run the payment, and come back and all that stuff. So there will be a motivation for the consumer to switch, but it's not being educated, or do you see any security issues? What do you see from the Visa perspective?
I just think it's behavioral, frankly. I think there has to be an incentive to change the behavior. Maybe you get a discount, maybe it's more convenient, something like that.
There are clearly environments in which it has taken off, as you observed, and I think it may depend upon somebody leapfrogging. If something is already not prevalent, like in Kenya, they took off. So that kind of thing can happen. So there's another question here.
So, hi, I'm Arasu. We are dealing with mobile app security. So, one of the points that was raised by Dave was something like we will be using machine learning to do protection. Say, what if, not what if, the bad guys are going to use the same model and make it more threatening? How will you take care of it?
So I didn't follow the end of that, I apologize.
Right. So the question was, turnabout is fair play. What if the same kind of technologies that you are talking about that's going to defeat the attacks are being used to generate the attacks and defeat the defeaters?
There's no what if about it. they're way ahead of machine learning now. It's already out ahead of that, so that's the problem.
Yeah.
Actually, the way past that is another piece of this, which is already present particularly in onboarding technology for end users through automation. The critical thing that a machine learning algorithm in the hands of a dark actor is that it's going to look for errors, mistakes, seams, vulnerabilities. And frankly, most of the reason that we are non-secure is because we deploy manually with errors and we track all of our security policy in spreadsheets.
And there might be in future, there will be more frauds happening. It will not be the static one like he said. It might be just shooting up and just killing.
Yeah. I mean, but there's a whole, again, the cloud is already bringing some of this technology for us, right? The automation of deployment of workloads is way ahead of the automation of security policy going with it. But the automation tools are here. The machine learning technology is here. We certainly have the compute power. The problem is we don't want it as complex as it is.
But seems like the approach that we take, like one of the points that he said is we just not do the fingerprint, we also check for the blood flow. Right now the mobile app and the stuff at the end point, whether it is blockchain or the banking app, it's not actually secure.
That's correct, and that was my point. That was my point about component behavioral analytics. That is akin to the blood flow, where a cryptographic tag is akin to the biomarker. You have both of those things in concert, it's almost certain that you will at least get alerts. And then there's a whole separate thing about how do you get rid of the false positives, otherwise you can operate.
Yeah, and technology people always think there's a technology solution for everything, and often it's not. Think of the credit card, okay, 16 digits. It's a completely naked credential. It has no authentication associated with it. You literally have 16 digits on a card, and anybody can read it, take a picture of it, photocopy it, flip the back, take the CVV, the second verification method. And yet we still have very low fraud levels. And that's because we have a naked credential that flies around the world, but we have incredible real-time analytics that use machine learning and neural nets to look at things like velocity. So we see how many times was that card number used in the last 2 minutes. Amazon will do things like, why are TVs being bought in Moscow and shipped to a different shipping address? I've never seen this shipping address before. So I think you have to kind of get out of the mode of the credential may be naked, but there's other ways to track it, and it usually is with pattern matching and machine learning and what have you. And I always think it's shocking that we have a credential to get to your bank account with money that has no protection on it. It's in people's pockets. You hand it to a waiter on a regular basis. They can take a picture of it in 2 seconds, and still the payment system is incredibly secure because we've gone at it a different way.
Yeah, I mean, one thing, one paradigm that you should think in terms of is, let's say you were playing castles, castles when you were a kid, right? And you had some kind of a attacker and a defender, and you know you have to get to high ground. You know you have to prepare. You know you have to, before you launch your business, your application or whatever, you have to think about the mode. You have to think about your defenses. You have to think about your threat model. If you don't do that, if you react, then the problem is that you're chasing an already bad situation, trying to make it right. And some of the components that we've talked about over here are strong identity. What does that mean? Identity for applications, identity for individuals, right? And then you look at, getting, okay, well, what's my economic moat? How do this is the stuff that I invested in earlier that allowed me to understand my baseline transaction and what is not a baseline transaction. If you do that, then you'll be fine. And that is probably one of the reasons why you guys have seen a flat fraud rate, because you put in the investment. The problem is the vast majority of us, and this is where I go back to engineering education and computer science, for the vast majority, security is a topic left to the experts. And where are the experts? There are not enough of them, number one. They're not usually empowered, and the experts can't fix anything, because when you do the architectural design of whatever system you're building, the expert, you need to be there, and it's not there, and that's really what the problem is for the most part.
I like it. The age of clouds and virtualization, we have moats, and we have going to the higher ground. I guess higher ground means going to the cloud. Okay, we have another question here.
It just occurred to me that a lot of breakdowns, especially in security, I don't know, in compliance as well too, is that there's a level of trust, and that trust is broken. Applications trust the operating systems trust the infrastructure. Within transactions, one level trusts the next level or the previous set of circumstances or actions. Is the possibility of changing the model so that nothing is trusted and each step is always verified? Is there too much overhead to that?
Well, I mean, if there's any blockchain enthusiasts or Bitcoin freaks, they would say you have a trustless system based on cryptographic proof.
Yeah, that's a good one.
Yeah, with a lot of latency.
Here is a suggestion. People have tried zero trust models, and some of them have built fairly complex, nearly zero trust models. An example is, for example, Google's Beyond Corp. The problem is they're very, very hard to build, and particularly when you have to do a transformation from legacy to non-legacy, it's extremely hard, because now you have all the problems that we talked about earlier, exemplified by Visa, and then some. So what is a much more practical way is to look at it is you have the legacy stuff. Be very careful about who can access it. Inside this is kind of like the firewall model, but cascaded out. There is pockets of stuff which is inherently insecure. And you have to be very careful about who can authenticate to it, machines, users, who can go there. And then you have the new stuff that you're building out now. That's where you can focus on a zero trust or close to zero trust model where everything required authentic. It's wide open, but everything has to be tested, everything has to be authenticated, everything is encrypted, and so on and so forth. That's a much more practical way to think about it.
I don't think that we want to get rid of trust, right? I think, so for HPE generally, hardware root of trust is something that we have invested tremendously in, and it's something that we've had to evolve as we brought decomposable, disaggregated systems to market like blade servers. It's one thing to have root of trust on a discrete server that is all bolted together and you can tell if it's ever been tampered with, and you can encrypt at the edge, and you can have keys fused into the silicon inside that are unchangeable. And you can say, this thing, I can say that the keys are legitimate and I have some ways of swapping them and I have a wonderful root of trust in this device. But when you go to a blade server, now you're connecting things together and you want to treat it as the same thing. So what do? Root of trust to every single component in the blade server, from the management modules to the compute modules to the switches that are inside creating the fabric. And the answer is yes. And the reason you do it is because we, say again? I thought there was some.
There's an Alexa in this room.
Is there?
I think you just bought a TV.
Yeah, so we should do it there. The problem with the disaggregation of the stack is, there's one thing that we can never trust. That's the internet. You can't trust a wide open network. We already presume that the network is open. And when we go to cloud, when we first went to cloud, we were under this mistaken assumption that because we're in this environment and things are connected together in some data center, that that's trustworthy. It's not. We need to treat the network to some degree as untrustworthy and apply sort of either gateway or analytics functions that look for departures from the trust model so that we can identify and remediate them. But the network itself is not trusted. No one trusts the network, especially because it's IPv4, which means there's also no identity. You don't know that that IP address maps, you don't know what it maps to. Everything is private.
So you are at 8 o'clock, so I think we are at the kind of like the end of the regularly scheduled programming. I know that some people have additional questions, so there is still time to network. Please come up here and please feel free to ask questions. I did want to, okay, here.
Good evening, my name is Keshav. I have a question more to do with what Dave was suggesting on identity management of everything, not just a person or an end user or thing. Any process, any thread, anything that happens in your computer environment. Have you heard of something called deterministic security that was explained by one of the IDC analysts in RSA? Very, very interesting concept it was.
Do you know who the analyst was? I haven't heard the term.
Forgetting the name.
I'll look it up.
Yeah, but it has to do with exactly what you were describing. Everything out there in the computer environment has to have identity, and every data generated has to have identity in terms of proving back and forth. So this is kind of an underlying ethics associated with security.
Yeah, I think the phrase deterministic security is fraught with some difficulty in the sense that we're never going to be deterministically secure. Frankly, I don't even think we will if we get quantum security. I don't think we're going to be deterministically secure. Someone will find a way around it. However, the attempt to be deterministically secure is going to be automated. It has to be machine instantiated because if it's humans that are doing it, it will be totally indeterministic.
So I think one thing I would like to close with is thank you very much for the panelists for the insightful comments. For everybody in the audience who has asked some really interesting questions. If there are entrepreneurs in the audience who are really eager to go and take a crack at solving those problems, the Fabric net is open. Please come and talk to us. So we'd love to engage you in that discussion. So there is still some, I think, drinks. I see some cookies. I don't see any 420 out there. Don't ask me for that. So go ahead and have at it. Please interact with the panelists if you have further questions. And this is a wrap. Thank you.
Rajan. Say hi.
Fantastic. Thank you.
Are you going to be there?